Hello, this is question 3 from the 2007 MAT. They've given us an integral here, so we're integrating over x, but the integral is a function of c. So c is some real number, they tell us here, not just an integer, it's just a real number. And c is transforming this function of x that we're integrating. We've got a quadratic here, and c is moving it left, right, up and down, such like. And then we're integrating. So it's asked us here for the first part of the question, sketch y equals x minus 1 squared plus 1 for the values minus 1 to 3 inclusive on the axes below. Show the area represented by the integral I1. So I'm assuming this is I1. This is the function we're integrating for I1. So you see if we put c is equal to 1 into the guts of this integral, then we get x minus 1 squared plus 1, which is what we're plotting out. Okay, so we've got y equals x squared, move 1 to the right and 1 up. So 1 to the right and 1 up. So we're going to have our minimum here at 1, 1. What else are we going to have? We're going to have, when x is 0, we are going to have minus 1 squared plus 1. So at 2, so it's going to go through there. Of course, this is going to be symmetrical, so we can say at x is 2 is also going to go through 2. When x is equal to 3, we are going to have 4 plus 1 is 5. 1, 2, 3. Right, they don't even have space for 5 on here, so this was well planned, wasn't it, by whoever wrote this question. But it's going to come out somewhere up here and somewhere up there. I'm actually going to run into the text of the question. So anyway, let's draw those out into something as smooth as I can manage on here using this pen. So you'll do a bit better than that, drawing it out on a bit of paper. But that sketch that out, and then we need to show on the graph the area represented by the integral, and that's going between 0 and 1. So we just drop that down there and shade in that, and then we can say, yep, that is what they called it, I1. Okay. So a little bit rough, but that's what you get drawing on a screen. Without explicitly calculating I of c, explain why it's greater than equal to 0 for any value of c. Okay, so that's telling us that these areas are always positive. These areas are always above the x-axis. So we need to show that the inside part here, the function that we're integrating, is always going to be above the x-axis. So that's what we need to show on this. So we've got x minus c squared plus c squared. So we've got two things that are squared added together. So that is going to be greater than or equal to 0. And then we're adding something which is greater than or equal to 0. So therefore, it's all going to be greater than or equal to 0. So we can say that this never drops below the x-axis, greater than or equal to 0 for all values of c. There we go. So that's good. Might even want to put in brackets, I don't know, no negative areas. Right, now we need to actually calculate I of c. So we need to do this integral. We actually need to make it so. So I of c is going to be, let's integrate this. There's not a lot to integrate. We're going between 0 and 1. So x minus c all squared, that's going to go to 1/3 of x minus c cubed. Then we've got c squared is just a constant, so we're adding on c squared multiplied by x. What's that giving us? That is then giving us 1/3 of 1 minus c cubed plus c squared. Then we're going to have, what are we going to have on this? That's going to be, if x is 0, we've got a minus c cubed and then a minus on it. So that's going to be plus 1/3 of c cubed and then minus nothing. Right, okay. So we've just got that put together. Let's expand out this cube then, this bracket here. Let's take the minus 1 out the front. It's going to be easier. So let's treat that as minus 1/3 and then expand out c minus 1 cubed. So minus 1/3. So c minus 1 cubed is going to be c cubed. Then we'd have minus 3c squared plus 3c minus 1. I just find it easier to not have the minus sign on the c when I'm expanding those out. And then we've got our c squared, and then we've got plus 1/3 of c cubed, which is handily going to cancel. So our c cubed have cancelled. What have we got for c squareds? We've got c squared plus a c squared, so 2c squared. For c's, we've got minus c. And for numbers, we just got a straight plus a third. Okay, so that wasn't too bad. What is the minimum value of I of c as c varies? Right, so this is our I function of c. So let's differentiate that. And we will get 4c minus 1. Therefore, we get a minimum at c is equal to a quarter. So the minimum I as a function of c is equal to I of a quarter, which is equal to 2 divided by 16, so an eighth, minus a quarter, plus a third. So that is going to be a third minus an eighth. So we're going to have to go over 24 and say 8 minus 3 over 24. So that's 5 over 24. So far, so good. What is the maximum value of I sine theta as theta varies? Right, okay. Let's have a look at that then. This has got all the hallmarks of me running out of screen here. I sine theta, 2 sine squared theta minus sine theta plus a third. Is that going to require calculus, or can we do this by inspection? We're going to be able to just look at this because, yeah, clearly we're going to want if sine theta is minus 1, then that maximizes the middle term because we're going to get minus 1 gives us 1, and it also maximizes the first term. So yeah, we're happy days on this. So we get a maximum when sine theta equals minus 1. So that's good. You can see that from the graph. Sorry, I'll just put this in and then we can come back to that. So if sine theta is minus 1, then our maximum of I sine theta is going to be equal to, what have we got? We've got 2 plus 1 plus a third. So 3 1/3. 3 1/3, just about creeping out on the screen. Yeah, you can tell this from the graph. So if you were actually going to plot out sine squared, which of course looks something like this, going to be hitting zeros, going between 0 and 1, and then you plot out minus sine theta, which is going to look something like this, then they're going to coincide at maximum points here at the same place. Yeah, they're going to have that same spot when you've got theta is 3 pi over 2. Then you're going to get the same value for both of these. You're going to get minus sine theta and sine squared theta both being equal to 1 when theta is 3 pi by 2. So yeah, you can see it in the graphs as well, but it just comes out inspection on this. I suppose you could go through the calculus, but there really is no need on this in order to see what the maximum value is going to be. So yeah, that wasn't a bad question all in all, fairly straightforward.